So yeah, today's topic is the KEDA Kubernetes event-driven autoscaler. And to me, I think that's pretty interesting, pretty relevant to my personal interest, because I work for a company named Container Solutions. So I have to do with containers, but I'm also very interested in serverless. And I think that KEDA is a great way to bring some of the serverless goodness, the on-demand compute, to Kubernetes. So I'm excited to hear more about that from our first speaker, Tom Kerkhove, who's a Azure architect at Codit and one of the maintainers of KEDA. Hi, Tom. How are you doing?
Hey, thank you for having me. How are you?
I am great. Thank you very much. Could you tell us maybe in one or two sentences what you will be talking about today?
So today I'll talk about how you can autoscale without KEDA and how we make it easier for you to scale your applications with KEDA. And then I'll show you how that fits in the big picture of autoscaling Kubernetes in general.
Cool. Awesome. And so if you would have the one thing that you want people to take away from your talk today, what would that be?
Don't focus on the scaling infrastructure, focus on your application. So use KEDA.
Nice. All right. That sounds really exciting. So there will be a Q&A session after the talk. So you can put your questions in the chat or on Discord, and we'll get them here and we'll ask them after the talk. So if you're ready, Tom?
Yeah, I definitely am.
So take it away.
So let's start talking about Kubernetes and how you can scale with what is there out of the box. So I will share my screen. Actually, it is shared. So if we could pull that in the screen, over here you can see that we have a Kubernetes cluster with 4 workloads. And typically you would add a horizontal pod autoscaler for your workloads. And then you would have this scaling infrastructure of Kubernetes itself, where you basically use custom metrics or external metrics to pull the information from outside the cluster to make the decisions. For example, if you're processing an Azure Service Bus queue, you typically want to scale based on the amount of messages that are waiting. Out of the box, that is not supported. So you have to use something like an Azure Monitor metric adapter to get the metrics, bring it inside the cluster, configure the HPA to use those metrics and scale your application. Now, if you also rely on something else like Prometheus, you need to install another metrics adapter to get the metrics. But the problem is you can only use one metric adapter in Kubernetes. So actually, you're kind of blocked already. So there are ways to work around this, like you could use a tool called Prometer, bring Azure Monitor metrics and Prometheus and fully rely on Prometheus. But it is still a lot of hoops to jump through. So what if you could just use KEDA, which has a variety of scales out of the box. KEDA knows how to work with these systems, and you can just focus on your applications and you use a scaled object, basically saying, hey, I want to scale on Service Bus queue, and when the message count is more than 100, add an instance, for example. So by doing that, KEDA will basically use a scale controller behind the scenes, which then uses the HPA and pulls all the metrics for you, but you don't have to worry about any of these things. You just define what you want to scale on, what the criteria is, and let KEDA manage all of that stuff. So you can really focus on the application that you have. So why should you use KEDA? One, it is super simple, but we basically allow you to auto-scale practically anything. We can scale deployments, we can trigger jobs, we can scale other resources that implement the /scale sub-resource. For example, Argo CD can be scaled with KEDA. Other tools out there already are adopting KEDA. And we have more than 25 scalers. I think we're almost nearing 30. So we keep on adding them. But if what you need is not supported, basically what you can do is you can write your own. Either you can contribute it back, of course, which would be great, but you can also add an external scaler or an external push scaler with your own logic, or you can bring your own metrics API, which basically gives the information for us and we'll make the decisions for you. Of course, you need to authenticate with all these systems. So we allow you to reuse the authentication from your workloads, or we also have the more production grade authentication, where you could use a trigger authentication resource, which basically defines how to authenticate, or even use a pod identity. So in the Azure space, that's called an Azure Managed Identity, so that there are actually no secrets involved at all. Now, another interesting fact is that if you have workloads running, but there is no work to process, we'll also scale down all the way to 0, so that we can optimize your cluster resources. And early, now I have to say last year because it's 2021, but early 2020, we also submitted to the CNCF as a sandbox project, because initially it was started by Microsoft and Red Hat as a project, but because we wanted to be vendor neutral, we decided that CNCF really is the best place. And they also help us govern the projects. Now, if we dive a bit more into detail, we're not reinventing the wheel. Keda is basically extending Kubernetes. So for example, we have one metrics adapter for all our scalers instead of one for every independent system. Then we have the scalers and the controller. And then basically we feed those metrics to Kubernetes and we use horizontal pod autoscaler ourselves. So instead of building all that logic ourselves, we just feed the metrics to the HPA. If you want to scale down to 0, we just remove the HPA and scale your workload for you. So we're just extending, which is super important. We do not want to reinvent the wheel. So that's really on mantra. Now, why is Keda important? Imagine you have a cluster with 2 nodes and you start auto-scaling. That's where Keda comes in. But at some point, you'll reach the maximum capacity with all those nodes. That's where you have the cluster autoscaler. So then it starts adding instances and adding instances until you have enough cluster resources. Now, if you have a high-scale system, sometimes the cluster autoscaler can't even keep up with all the capacity that you need. So you need to overflow. And that's where virtual nodes is really great. So virtual nodes is Azure Kubernetes Service specific, but it builds on top of Virtual Kubelet, which is an open source project as well, which allows you basically to move your Kubernetes workloads on ACI, but without you noticing. From a Kubernetes control plane level, it is still Kubernetes workloads, but that allows you to basically handle those spikes. So this is really the auto-scaling sweet spot, where combining these 3 components, you really have a high-scale application. And then the best thing is if your load goes all the way down, you can even fully rebalance back to your 2 nodes. So you're not only optimizing for the cost, you're also doing our environment a pleasure by not wasting resources, which are running without being used. So this is a bit Keda in a nutshell. That's it. But basically, our goal is really to make it that simple for you to scale those applications. You can easily get started. Just install our Helm chart. The only caveat is we do not support HTTP-based autoscaling today, but I know a very intelligent guy who might be the next speaker, who knows, who will talk about that. But that's the elevator pitch for Keda. Maybe to extend, why is it called event-driven autoscaling? While we fully rely on the metrics that are provided, basically we will do all of that for you. And in the serverless space, it is very similar. Imagine that there's a message arriving in the queue, it will automatically trigger your workload. Now with Keda, it's the same experience. Keda will automatically see that there is work to process, and it will start up your workloads to handle them. So you could use the typical daemon approach where you have a deployment, which is running, or you could also use the Kubernetes jobs, which are the more the serverless way, where basically you spin up a process, it does some work, and it just runs to completion, and that is it. So a good example of that is Azure Functions. Azure Functions is fully open source. You can run it practically anywhere. And you can basically take your Azure Functions from within Azure, run them on Kubernetes, and basically scale them with Keda as if it would be running on Azure. So basically, you're bringing serverless where you need it. That's also one of the reasons why Microsoft started this project. It comes from the Azure Functions team, because this is super important for them. If you're an Azure Functions CLI user, basically what you can do is you can do func deploy Kubernetes, I think is the command. I don't know it by heart. And then basically it will deploy it to Kubernetes, and it will also add our scaled objects and scale it with Keda for you. So actually you won't even notice that. And as of, I think it was yesterday, we merged support for Keda 2.0. So that's coming very soon to your Azure Functions CLI. So I don't know how we're doing on questions, if we have any coming in.
Yeah, we can do. So if you are done with the talk for so far, we have 2 questions so far, and you can always drop in more in Discord. We'll see it here. I'm on Discord as well now. So the first question we have, I don't know if this came from the public or from Suzanne directly, but the question is, can we scale, for instance, AKS to 0 nodes?
AKS allows scaling to 0 instances. We don't support that with Keda because we focus on the application. But AKS allows you to do that out of the box. I think it is only supported with the Azure CLI for now. So Cluster Autoscaler does not support that yet, I think. But I know they're actively working on that. So if you go to the roadmap, you can actually see that over there.
Oh, awesome.
Important. If there is no work to run in your cluster, would be good to scale it down to 0.
Yeah, absolutely. What else is on the roadmap that you find interesting or noteworthy to call up at the moment?
Yeah, so the HTTP work is super important, because only a subset of the workloads that you typically run are depending on the queue or whatever. The majority of them, however, is relying on HTTP. We build a lot of APIs, REST APIs. We do service-to-service communication, etc. So we need to make sure that those endpoints are available and that we scale them out and in accordingly. The tricky thing is HTTP is harder to scale than the queue, for example, because with a queue, what you do is you know how many messages are waiting. While with HTTP, you rely on synchronous communication, so you cannot predict how many calls will be coming in the next 5 minutes, for example. So today our recommendation is just scale on CPU and memory, because that is a good foundation. But what Aaron is working on is more advanced and also supports scale down to 0 even, which
great.
Back to the save resources. Then other things we're doing is we just released Keda 2.0 in October or November, I can't remember. But since then, we already added 2, 3, 4 scalers even. So we're constantly extending that, so that the true power of Keda is the scalar portfolio. So if you look at Keda and you don't see the scalar that you want, please do let us know. And then we can also either consider them, or if you want to contribute them, that's even better. Then from a management perspective, what we also want to do is start emitting Kubernetes events, so that if you have a tool, if you want to build a tool that extends Keda, that we provide that extensibility and that observability. For example, if we cannot scale your workload because it is misconfigured or we cannot authenticate or whatever, instead of checking the logs, it would be better if you can just subscribe to those events and automatically react, which basically gives a faster time to remediation, which is a lot better. And then more on the governance side is, okay, we are now a sandbox project in the CNCF since January 2020. Our community has been growing, our customer base has been growing, and we feel that it might be time that we start looking at CNCF incubation, graduation. So we might check what the process is there and what it takes for a project to become an incubated project. So those are the main topics. If we go to our GitHub repo on KEDA core/KEDA on GitHub, you will also see that we have a public roadmap, which we introduced recently. So we start committing to these kind of things, and then we start rolling them out so that you can have an understanding of what is coming. And again, we are super open. So if there are things that are missing, just let us know and we will definitely consider them. So we fully rely on the community as well, because we as maintainers will not we're not the kings of the project. We're just the captains of the ship, and we will steer the ship where the community thinks it should go. Obviously with some limitations, but we're building this for the users, and we feel that this closes a big gap. And if we feel that this is no longer the case because we're doing it wrong, we will most definitely make sure that everybody likes how the project is going. And like I said, it has been growing, and we now have more than 2,800 stars on GitHub and more than 100 contributors, so that's really great. We also have other tools adopting KEDA inside their core, be it Apache Airflow, Dapper also uses it. We have Vision, we have Knative, all these kind of tools, and even Alibaba Cloud standardized on KEDA to do their application autoscale. So that's really great. Because that shows that a major cloud vendor like Alibaba Cloud relies on our software, which is a nice token of appreciation, in my opinion.
Yeah. And is OpenShift also relying on KEDA? I think that OpenShift is doing with something with KEDA and Knative, if I'm not mistaken.
Yeah, so Red Hat is one of the leads on the project. We have Sibirnek, who is really contributing a lot of stuff, and he also is up to speed on the Knative side. But I don't know if they use it inside of OpenShift itself. We don't have any visibility on that. It is possible. If it would be, then it would be nice. But I can speak about that.
Awesome. So can you maybe also elaborate a bit on how the project is being run? Like, what is the process for defining the roadmap? Who's involved? How do you design? And maybe also, how could I get involved if I'm interested now to contribute?
Yeah, most definitely. So we do bi-weekly stand-ups. Actually, it was yesterday, 5 p.m. Central European time. So we always welcome people to join, even if it is just to hear how it's going, to discuss topics they want, or to raise concerns. And there we just discuss those topics. So that's one way to get started. Another one is to get involved on our GitHub repo. So join the issues and share what you think about new features. Join the discussions and help people get unblocked. And also join the Kubernetes Slack, where we have a KEDA channel. So those are the starting points of our community. Of course, sending documentation improvements is the easiest way to start contributing back. But if you have an idea that you want to contribute, just open an issue. We typically then discuss if it makes sense or not. because we don't want you to waste hours on a feature that we don't think is reasonable for the project. But if we like it, we're more than open to have them. We will also guide you through the process. And then we basically take you from idea all the way to a shippable feature in Kada. Now, from a governance perspective, we're very flexible again. So we have 5 maintainers. So we have Zibirnek from Red Hat, myself from Codit, and then we have Ahmed, Jeff, and I can't come up with the name now, but also from Microsoft, from the Azure Functions team, Anirudh, sorry, and where we just discuss more the long-term roadmap. Let's say, where do we want to go? What's the biggest gap? And with which projects do we think we need to collaborate? Because like I said, we don't reinvent the wheel. And then we just reach out to those people. For example, with the HTTP work that we're now doing an experimental part, but in parallel, we're also checking how we can rely on other projects. For example, the Service Mesh Interface project, which is an open specification, has information that we want. We can use it for Service Mesh, but what if we could use it for a service in Kubernetes or an ingress? So now we're checking, okay, can we take it to the next level? Can we bring it inside the Kubernetes core? All of those chit-chat things are what we're also working on. So it's not all. So people think open source is always about the code. It is 20% of all the work. You need to do documentation, automation, governance, tweaking your GitHub organization, working with the community. All these things also take a lot of time. So we prefer that people can contribute features, and then we do all the boring stuff. Which takes more time than people think. That's overall how we work. We don't tend to over-engineer with full documents that you have to write with change proposals. I think the project itself is too small for that, and also it discourages people a bit. But we just have an open door for everybody. Even if you're new to Kada, speak your mind. If it is not clear, then either we have to update our documentation or make it easier for you. Because for me, it is super important that you don't need to be a Kubernetes expert to be able to auto-scale applications. You should be able to get it going in 5 minutes. And that's something, a trap we typically fall into. We do open source projects, and we always take from it from a technical side, but don't forget about things like documentation, user experience. If you don't have all of that, then nobody will use your project because they can't figure it out unless they have to read the code. And that's not a nice experience, in my opinion.
Right. Yeah, that makes a lot of sense. And you're absolutely right that project management and product ownership is a big part of running an open source project or organization that you just kind of don't think about. So I can imagine that this takes a lot of time. We still have a couple of questions. So there's one question coming in from Discord, which is what is one thing you would like to see that is not yet on the roadmap?
It is on the roadmap, but I think it will not happen soon. So I'll use that. And that is a dashboard, basically showing you how you are scaling over time, how it is spiking or not. And then we can also throw in predictive scaling, which basically shows, okay, we will think that tomorrow you'll need that many instances, and then we can plug that into the cluster autoscaler and predictively scale the cluster for you based on the work that we think you need to have. Because having an autoscaler is good, but having a good autoscaler is harder, because scaling workloads is not the only thing you have to worry about. You also need to be able to get notified so that you know that when you are scaling, so that you can detect scaling loops. For example, if I deploy my auto scaling and in 5 minutes I go from 1 instance to 20, then I think something is either misconfigured or you're a successful business. I hope it's the latter. But if that is not the case, you will burn a lot of money. So observability is important. That's where the dashboard also helps, but also the Kubernetes events will help there. So I would say that is that would be my pick. Of course, there's a lot of things that we could also improve. Like we've been looking at, should we integrate with Cluster Autoscaler? Because we know if we scale, most probably the cluster will need to already start scaling. So these kind of more advanced things. And the HTTP one is actually my biggest feature request that is on the backlog, because I know that a lot of people just need this. So that's why I'm happy Aaron is doing that work.
Awesome. Cool. I think we have one last question, unless there are more coming in through Discord. You can still ask your questions there. We're still monitoring it. But Nick was asking a question earlier, whether it would be possible and make sense to connect KEDA to Cosmos DB change feeds.
Change feed, you can definitely do that. It acts a bit like Event Hubs, where it is just an event stream, and you need to checkpoint where you have been processed, what you have been processing already. So it is most definitely possible. It definitely makes sense. However, we do not have that scale yet. I think it is on the backlog, but it's possible, yeah. It's a typical scenario where people process what has changed in the Cosmos DB account, and then they just try to catch up. So that would be a call out to Nick. Go to the issue on GitHub, give it a thumbs up, and then we know we should do it.
I was going to suggest to Nick to just go there and take the issue and do it.
Yeah, also.
It's all in Go, so it's...
go for it.
Right? Exactly. Cool. So I think that's it for now. Will you still be around on Discord or in the chat if people have more questions later?
Yep. I will definitely be around.
Fantastic. Well, thank you so much. It was really, really interesting. I'm going to definitely take a closer look at KEDA now. Maybe if I find some time, I'll contribute some documentation changes or something.
Yeah, it would be great. Thank you very much.
We'll check out the stand-up. It sounds very interesting.
Yeah, I'll paste the stand-up and the documentation in Discord.
Fantastic. Thanks so much again, and have a nice day. We'll move on now with the next talk, I think.
Thank you very much. See you around. Bye.
Thank you, Tom, for joining us. And if you want to learn more about the project and how you can contribute and what they are looking for, we did an interview with Tom, and you can find it here on the website. If you go to the interviews, you can just look it up and listen to that project. Or actually, Tom submitted 2 projects, if I remember correctly. One is Proctor. No? Proctor, right? Tom? He's still there.
It's called Prometer.
Yes, that's it. Yes. That's it. Yes, and can you tell us something about that project while you're still there?
Yeah, I actually can. Actually, today I released Prometer 2.0. Prometer basically brings Azure Monitor metrics where you need them. So basically, Prometer scrapes Azure Monitor metrics, and it allows you to push them to Prometheus, StatsD, or Atlassian status page. And actually, full circle, I started Prometer because I wanted to auto-scale Kubernetes workloads. There was no Azure Monitor metric adapted back then, so we were looking at the Prometheus one, and I wrote Prometer as a bridge between the two.
Well, that escalated quickly.
Yes, exactly.
Well, amazing. Once again, thank you for joining us, and people can find more information about your other cool project, Prometer, at prometer.io. You can find the link here below. So thank you for joining us. Now I'm going to leave you alone.